Memory might not be something that we see, but it's constantly changing and it's constantly shaping how fast and stable and efficient our applications really are. So in today's episode, we are going to dive into one of the most fascinating and often misunderstood areas of computer science, memory management. Hello everyone, and welcome to another episode of the Tech Odyssey podcast. My name is Mike, I'm your host, and here on Tech Odyssey, we explore the world of software development through simple stories, real-world examples, and lessons that you can actually apply to your career. Whether you are early in your career or just leveling up your skills, or even if you are not in the tech industry at all, this podcast is your guide to understanding how tech really works behind the scenes. I created this show to help developers grow, not by memorizing things, but by actually understanding them. So in each of these episodes, we are breaking down a technical concept in a way that is clear, it's practical, and actually enjoyable. So let's get started with today's topic. So, have you ever closed an app on your phone only to see your battery life drastically improve? Or have you ever had an app in your phone or in your computer that suddenly crashed with the error out of memory? Memory might not be something that we see, but it's constantly changing and it's constantly shaping how fast and stable and efficient our applications really are. So in today's episode, we are going to dive into one of the most fascinating and often misunderstood areas of computer science, memory management. When you run a program, it's not just code getting executed. Behind the scenes, your system is constantly juggling data, deciding where to store it, where to free it, and how to keep things running in a smooth way without crashing. Every time that you create a variable, every time that you load an image or start a new process, you're asking for your computer for a piece of its limited memory. And how efficient you manage that memory, it determines whether your app feels butterly smooth or painfully slow. So today, I want to take you on a short journey through how computers actually handle memory, from allocating space for your variables to cleaning it up when your program is done. By the end of this episode, you'll understand, first, how memory is actually organized inside your system. Two, the difference between the stack and why that matters. What garbage collection really does. Why memory leaks actually happen. And finally, you will understand how memory helps you faster, safer, and more reliable code. So without further ado, let's dive in. First of all, let's understand how memory is organized. When you launch a program, your operating system gives it a chunk of memory, imagine like a small apartment. Inside that space, there are different rooms for different purposes. There is the stack, where your local variables and function calls live, the heap, where larger or dynamically created data lives, and there are also a few other areas like static data and code sections. Think of it like a hotel. Your stack is your quick check-in, check-out area, where you just stay for a moment and then leave immediately. And the heap is more like renting a long-term apartment, which is flexible, but if you forget to move out, you still pay the bill. So, let's dive a little bit more into these two things, the stack and the heap. The stack works like a stack of plates. Every time that you call a function, a new plate gets added. It stores local variables and it returns addresses. When the function ends, the plate is removed and it frees up space instantly. That's why stack memory is super fast, because it's tightly managed and it's predictable. The heap, on the other side, is much more chaotic. You request memory manually in low-level languages like C, for example, or through objects in higher-level languages. It's flexible, but it's also very prone to clutter if you are not careful. This is why garbage collection or manual cleaning comes in. And let's speak a little bit about this, the garbage collection. Languages like Java, Python, and C# use garbage collectors to automatically clean up unused objects. But here is the thing. Garbage collection is not magic. It's just another process running in the background, which is scanning for memory that your program is no longer referencing. It's like a janitor cleaning up rooms in your hotel, but if the janitor starts cleaning up rooms during rush hour, it will slow everything down. That's why understanding how the garbage collector works and when it runs can help you write more memory efficient code. But even if you have a good janitor, like a finely tuned garbage collector, things can still go wrong. Sometimes the room never gets released, the light stays on, and the resources keep piling up. That's when you run into one of the most frustrating bugs in software development: memory leaks. A memory leak happens when your program keeps holding into memory that it no longer needs. Imagine checking out of your hotel room, but keeping the key card. No one else can use it, and the room stays booked forever. Leaks can be small, like just a few objects forgotten inside a list, or massive, that slows everything down. It consumes your entire heap until the system eventually crashes. In languages with garbage collection, like Java for example, leaks still happen. They happen when you keep referencing objects you no longer need anymore. So the lesson is that you should always know what you are holding on to and let go when you are done. At the end of the day, memory management is not about micromanaging bytes. It's mostly about performance, about scalability, and about stability. When you understand how memory flows through your app, you can design systems that don't just work, they fly. And next time that your app feels slow, you know that it's not just bad code, it might be just memory quietly asking for some attention. And that concludes today's episode. A quick dive into how memory management keeps your program alive and efficient. We explored how memory is organized, what the stack and heap do, how garbage collection works, and why leaks happen. If there is one takeaway that I want you to live with, is this: good developers don't just write code that makes things work. They actually understand what happens after the code runs. Because once you know how memory works, you start writing programs that the machine actually loves to execute. And that's it. Thanks for tuning in to one more episode of the Tech Odyssey podcast. I am Mike, and I will see you in the next one, where we will keep exploring the world of tech one step at a time.